Hello there, my intrepid mathematicians. Mr. McBean here. I've got a very interesting skill for you to try out here to develop. It is sort of near the end of the road of our analysis and use and investigation of quadratic functions. You guys have done a lot of work with them over the years, and so this is kind of close to the icing on the cake here. So what we're going to try to do is take a standard form equation here and turn it into a vertex form equation. I'm going to shoot you a little video here, but I'd like to see you guys doing your work as well. Now that might be you working out your equations and taking a picture after. Maybe do it on paper and take a picture after. That's all right. Oh, it's not very exciting. I'd really like, and I super enjoy seeing you guys make these videos and explain everything so I can see your thought process and listen to you analyzing and chewing your way through these problems. It helps me understand your thinking better, and also helps me if something goes wrong. It helps me explain maybe what direction you need to go or what things you might have misunderstandings about. So it's a great teaching and learning tool. Okay? So try to find yourself somewhere quiet in the house, hit the record button and just go at it. I'm having a hard time right now. I've got dance lessons going on in the living room. It's crazy. Actually, I'm in the bathroom right now just to find a little bit of peace and quiet. So here we go. I'll take you through how to solve this. So to get started on this, you have to focus on this middle term. This middle term is going to tell us a lot about what was the original square that would give us negative 12x after collecting like terms. So I know that sounds really tricky, but think of it. This negative 12x here that's highlighted in green was a product of a FOIL that resulted in two x terms. Remember, when you do FOIL, you get an x squared, you get 2 something x and something x, and then you get your plus 3 at the end, for example. So this negative 12x actually comes from 2 x terms, and we got to try to figure out what was the original 2 x terms that added together to make negative 12x. Well, if you go to any FOIL method, any ones that you've done so far, you'll realize that both of the something x terms in the middle of the equation when you collect like terms are the same. So it's like 2 identical numbers. So what 2 identical numbers can we add together to get 12x? So if you kind of go back a step based on the work that you just did, kind of going backwards through that collecting like terms and FOIL and everything else, really this must have come from something that looked like this in the expansion. So we're going to kind of go backwards. And so now if the middle term is negative 12x, must have come from minus 6x, which really means the original function must look like this if we want it to be expressed in vertex form. In order to get minus 6x, we would have had to start with this perfect square. But the one thing that's missing here is if we expanded that perfect square from here, we wouldn't get plus 3. We'd get something else. We just don't know what. So now it's time for us to do a little engineering. Engineering is when we make something happen and something sometimes doesn't seem possible. So we've got to sort of force ourselves on it here and make it happen. So look, if we want to change this into a perfect square, x minus 6 squared, then we can't use plus 3. Plus 3 wouldn't be appropriate, it wouldn't work. What we really need is to figure out what goes here. And that would actually be pretty easy if we have x minus 6 inside of the square bracket here. I'll use my little highlighter. We've got x minus 6 squared. When we FOIL this, we'd have -6 times -6 to give us this last number. So -6 times -6 is, it's 36. Okay, so if we have to add a 36 into what we're working with, we have to force it. The only way to force x squared minus 6x minus 6x plus something to become this perfect square, we have to add this 36 into the function, okay? And what you also know is that you can't just randomly add numbers to a function and expect it to still be equal. If you added 36 to this side, then what would you have to do to make sure that that equal sign was still working? Well, you know you'd have to add 36 on the other side. So you'd have like y plus 36 equals x squared minus 6x minus 6x plus 36 plus 3. That would be fair. Let me show you something a little bit different. What if we just do this? How about that? Is our equal sign still equal? Well, yeah, technically, we've added 36 and we've also subtracted 36. So technically, we haven't done anything wrong. But what we have done is something super important. We've put together a perfect square. Or you could say we have completed the square, which is what they often say in the biz when we're doing this type of conversion here. So just to clean that up, I'm just going to leave our work on the left-hand side. On the right-hand side is kind of the thinking, right? The theory, what we're trying to achieve. And on the left-hand side, we actually have the work here. We now have x squared minus 6x plus 36. If we look at that in that little blue box, that is our perfect square. It is what we drew over here as our sort of target. This is what we've made now. So there's a connection between these two things. They're the same thing. So now we have manufactured or engineered a perfect square. So we can now rewrite our formula. Okay, so that's all the hard stuff. And now we just have to simplify these two last terms over here because we've got our perfect square. And we just have these two which we can combine. Okay, so there we now have our function looking like our vertex form. We've got our ax minus h squared plus k. Now you're going to see this done a lot of different ways from different approaches, but ultimately we're all kind of going to be doing the same thing. We're going to try to engineer a perfect square given the numbers that we're starting with by adding a certain amount, like in this case plus 36. We're going to have to also subtract that amount to keep the equal sign working, and then we'll condense it into that perfect square, in this case x minus 6 squared, and then whatever happens at the end is going to happen at the end. So I hope that this helped. I'm sure there's going to be lots of other videos and stuff out there online that'll help you. So check them out, see if you can make sense of this, and try those three. Please let me see your work or even hear your work as you go through them so I can give you as much help as possible. Okay, good luck.